Ahoy, ahoy. Looks like today is another Friday. Missing Ken. Ken, where are you? Ken? Hello, Ken?
Hello, Glenn.
Hey, there's
Here we
Ken. We
go,
got
Ziti
Ken.
TV.
We
It
are
must be Friday.
live again on a Ziti TV Friday. It must be Friday. Um, today we have something very special. We have another guest star. We have Andrew Martinez, who is
Hey,
going to be taking us on a tour of things called Spiffy Inspire, and we're going to see we're going to learn what those are. In fact, let's just do this. Let's pop this up, and we'll see what we're going to do is we're going to look at some cool new features that are coming down the ZD pipeline. What that means is not released yet. So if you want to rush right out and try this at home, you should know that this will not work just yet. But it is right around the corner. It's also clearly not going to be vaporware since we have Andrew here to give us a good demonstration. We
Andrew at
will
least is real.
Andrew, I can vouch for Andrew being real. Thank you, Ken. That is a very good point. He's definitely real. Not a robot. Not a robot. All right. So then we're going to look at this little overview that Andrew has prepared for us. What is Spiffy Inspire? Why Spiffy and Ziti is so good? And then maybe we'll even see it actually work and prove that it's not actually vaporware. So that's our little agenda. And with that, I'm going to look over to Andrew and see if he's ready. He's going to give me a thumbs up. Oh, there he is. I'm going to give him a thumbs up. I'm going to bring him into the stage. Let's take this off. And it's the three of us. Look at that. All right, cool. Well, hello, Andrew. Welcome.
Hello, how are you guys?
I am fantastic as ever. So glad to have you here. Very excited to learn all about Spiffy Inspire. I was told by a little birdie that you had this demo prepared all like last week. Is that true?
No,
No, it's not true.
no,
No.
it's not true.
Oh, geez, I thought
No,
you've had this in the can for weeks now. All right, cool.
no.
So when did you whip this all together?
About 2 days ago,
Perfect. Well,
slash
that's
this morning.
That's fantastic. Demonstrating the power of Ziti and the power of Andrew Martinez. I love it. All right.
Yeah.
Well, shall we get into it?
Yeah, we can.
All right. You're sharing your screen. Let me bring that onto the focus here. And now everybody see. Ooh. You and I were talking earlier, and I asked if you had a diagram, and I see that you have spiffied it up. You see what I
Yes,
did
I
there?
have. Yeah. So there's a number of features that have actually come out in ZD. One of those is the ability to delegate authentication to external JWT signers. So if you can get a JWT from somewhere and you can get a hold of their public signing cert, you can add them to ZD. That's actually released already. Actually, I'm sorry. No, that's staged to release.
I think
So
that's
that's
coming out in
that's
25.5, right?
that is 25.5. I thought 25.5 was already out, but we were having some problems in our smoke environment, so
Yes,
we're
we
trying to
crashed it
hammer those
today.
out.
Yeah.
Yes, we did amazing things with it.
That's always nice.
Um,
By the way, usually on ZDTV, I will start with a release note reading, but I don't believe we've had a release note yet. So we can look forward to that on the next ZDTV, maybe.
Yep, and I'll just real quickly just go into what those are real quick. So, um, so there's going to be external JWT signers. That's not really important for Spiffy. The one thing that is important is the ability to create identities
Could you make that just a
with.
teensy tiny bit bigger?
Yes.
There we go. Thank you.
Oops, you got to choose one. So there's now a new field in here called external ID, which allows you to set um, essentially an opaque string that to ZD we don't know what it is or where it comes from. But the reason it's interesting is because it allows you to tie subject claims from other cryptographically signed documents like a JWT or a cert back to a ZD identity. And when you're using external JWT signers, one of the things you're trying to do there is you're trying to match usually the subject claim, but we support it's gonna our capabilities are gonna be able to support any claim you want, like if you have an email claim in there or something
And
else. But
let's
usually it's subject.
pretend I don't know what a claim is. What is a claim?
A claim is it's a piece of data that is verifiable. as in the document is signed using cryptography that is externally verifiable. So, like if you try to muck with the values, it'll fail validation. So it's two things: it's data plus verification.
I
In
see. So
our
you would
case,
add you would add that claim into some document and send it to the controller, and the controller would verify it. Is that the idea?
yep, that is correct. And the reason external ID is interesting is because it allows you to bring in IDs from outside of Ziti and essentially map them to identities inside of Ziti. And we have capabilities to automatically create identities on the fly inside of Ziti in response to that. There's
Ooh.
some work that needs to be done, especially around JWTs, where they're not being created right now, but you can pre-create them to link them together. But that's going to be an additional feature coming out
And
probably in dot six.
if I can, what was the so it sounds neat. We can you said we can automatically create an identity. That's cool. What was the what drove that? Did we have like was there a desire to do this?
Oh, early on in ZD's development, there was we were talking with different potential customers, and one use case was mass pre-enrollment of mobile devices at a factory. So they would be able to pre-install certs signed by some CA that they control, and they wanted to know, can we do this so that when somebody just turns them on for the first time, ZD just figures out who they are, assigns them the right policies, and has them connect. And that's essentially where CA auto enrollment came from. That's the official name of the feature. So ZD allows you to add a third-party CA to it. You can verify that you own it, and then you can decide what that CA is allowed to do inside of ZD. One of the options is just have it do authentication, where identities exist and they come in presenting a certificate that's mapped to their identity, and then they authenticate. There's also auto enrollment, which does the former as well, but also adds if an identity comes in and we don't know about it, we can create it and then assign it policies. And then of course it can be disabled. And
So that's
now,
cool. Oh,
yep. And
sorry.
now
And
with
more?
the work I was doing for SPIFFE integrations, it's going to be also be able to take in a SPIFFE CA and SPIFFE IDs and have those come into the system and just work.
That is super neat. All right, cool. Thank you.
Yep. Yep. So so external ID. That's going to be a feature coming out in .5. This spiffy work that I'm going to show is probably going to be in .6, assuming there's no technical hurdles that I haven't already found
Coming
a solution
soon.
to. Coming soon, right? Um, so the next question really is if you're new to Spiffy and Spire, there's a question about what they are,
Yeah.
and it Spiffy is a set of specs that describe how ephemeral workloads can acquire cryptographically signed documents, so that in the current implementation of that they have available, that's going to be a JWT or an X509 certificate, and those documents essentially are ephemeral themselves. So we have ephemeral on top of ephemeral, and then we also have, and those documents essentially inside of them they have a claim. Inside of a JWT, it is the subject field. Inside of the X509 certificate, it's a URI SAN. And basically in both, it's just a string. It looks like spiffy colon slash slash, and then whatever path, URI path, host name that you decide to give it to uniquely identify it.
Okay, so you
Um,
said ephemeral workloads, and so if I will translate that into something that is a little less technical, that means some bit of work somewhere once comes online, meaning it's ephemeral, it's short lived, or it is created on demand, and then ephemeral JWTs means you have some way of creating short lived or on demand cryptographic documents, that strong identity kind of idea. And those strong identities have those claims that we were talking about before. Did I get all that right?
yeah, sounds correct.
Okay. Thank you.
Yeah. So what Spiffy and their reference implementation Spire allow you to do is to have machines or devices come online, work with a Spire agent to become to essentially to attest to verify who they are, and the verification capabilities of Spiffy and Spire are a talk on their own. but you can verify information from cloud providers. You can verify things like in this example, and the example we're going to use here from their getting started doc, it's going to verify that they're running on the right Unix ID, Unix user ID, which is going to be 1000, which also, since I'm running all this in WSL, happens to be um, the the WSL user, the default user that gets installed. So in SPIFFE, you have this concept of a server, and you have this concept of an agent, and what happens is the Spire server actually acts as essentially a CA. So they have their own root CA. They have ways to delegate it. In their default setup, it's just a CA on disk, which is really useful for this demo because it gets us easy access to the CA cert.
And
And then
CA meaning a certificate authority, meaning
yep,
the termination point of some trust. Is that would you put it that way?
yep, yeah,
Okay.
and that's having private CAs with a private, and when you have a CA and you have intermediates and you have certs and identities, it's called a PKI. Having a private PKI is becoming it's pretty normal these days for most security software, because you're trying to put as much trust in only yourself and not trying to delegate to public authorities, because while public authorities do their best and stake their reputation on remaining secure, they are not always secure.
Yeah, and what's
So
really cool to me about the whole third party CA stuff is like it sounds to me like Ziti allows you to not you as the operator of Ziti to not basically quote unquote trust Ziti itself. You can issue certificates from your PKI and inform Ziti that those certificates are valid, and then Ziti can just well, Ziti trusts you because you've installed it. Is that right? Do I have that
that's
correct?
correct. Yeah.
Cool.
If
Yeah.
you ZD, I mean, we offer tools to obviously ease the PKI setup, and we can generate the PKIs for you. But if you don't like that, you don't like some of the options that are in there, you can tweak them to your
Do it
heart's desire,
yourself.
as long as you know how to
Yeah,
do
in
it
fact,
yourself.
the quick starts all create a whole complicated PKI for you so that you can explore that too.
Yeah.
Would it be too much of a stretch, Andrew, to call a CA an identity provider?
I wouldn't use those terms because identity provider usually has it usually implies that there's some system you can interact with, or humans can interact with, or devices can interact with to i- in like over the network, over a network, over the internet is usually what most people think these days. Um, a CA is part of that solution, but it is not the whole solution. Like if you were going to talk about being an identity provider, I would assume you have some kind of standards compliance ways of interacting with them. Oddly enough, SPIFFE is one of those ways. There's also like OpenID, that would be another way. Or if you just support like simple bearer tokens that don't require lots of back and forth web
Okay.
traffic.
So calling something an identity provider definitely implies a framework, a standard way of interacting, whereas a CA is sort of a generic cryptographic root of trust under the PKI umbrella
It's part of
of
that framework.
ideas.
Yeah, a
It can
CA
be
is
used with
essentially
multiple identity provider or frameworks.
yeah, a CA is part of a PKI, and then PKI solely exists in order to create chains of trust. Um,
Cool.
but in just about every IDP, you're going to find a PKI of some kind, either in X509 or JWKS formats. Um, so back to SPIFFE and Spire. Um, I'm going to use those terms interchangeably. They basically just, since Spire is a reference implementation. So in Spire, we have a root CA, and it's going to generate at runtime a number of intermediates according to its design and setup. And then from those intermediates, it's going to sign leaf certificates. And those leaf certificates are usually what people consider their strong identity. That's the thing devices and software use. And so the way it usually works is there's some piece of software that knows how to work with the workload API that is part of the Spire agent. So Spire agent is spun up, it's registered with a Spire server. There's like a setup for that. It's similar, very similar to what you have to do for like a Ziti edge router and a Ziti controller. So that would be these two pieces over here on the left. You start your controller, then you register your edge router with your controller. It's pretty much the same thing. You start your Spire server, you register your agent. The agents usually live close to the workload because they need to be able to work with work with whatever you're verifying. So the agent is actually, in this demo, we're running everything on one server, just for, it's basically a development demo. But generally, like if you're whatever's handling your Ziti connections would live next to your agent, because the Ziti tunnel in this case is the thing that needs to get a certificate from Spire, and that certificate is what Spire calls an SVID, which is a SPIFFE verifiable ID. So you have a question, Clint?
Oh, I was just wondering. So you're what I thought I heard you say is if you were deploying this out in the wild, the Spire agent would be co-resident to ZD Tunnel in this case.
Yes, it would be.
Gotcha. So did
Or
you have to modify
they
ZD Tunnel to add the API to talk to Spire?
No, I haven't done. So that's part of the work that we potentially could do. They do have commands that Spire provides in order to work with the workload API and essentially just put the cert on disk,
I
and then I can
see.
have a ZD identity load that certain key and
So
use
you
it.
use like the Spire CLI to make a certificate, and then you can tell the ZD Tunnel to use that certificate somehow.
Yep.
Gotcha. Cool.
Yeah. Yeah. So we have our Spire server. It has its own CA. We're actually using the dummy CA that comes inside of their quick start guide. We have an agent we added to it. The agent is going to have its own intermediate that it's going to be able to issue SVIDs back to the ZD tunnel. There is going to be attestation that goes on. The agent is going to do. It's going to be based on a rule that we create, which the command to do that is this. Let me just make this a little bit bigger. It's at the bottom here. So Spire server entry create parent IDs. We're giving, this is the parent ID, which is going to be the parent host for I believe the intermediate, which is the trust domain, and then we're saying it's going to be, this is actually going to be our SPIFFE ID for the ZD tunnel, which is going to be example.org/workload, and then for attestation, we're saying the selector is it has to be running on UUID 1000. Since I'm running in WSL, my Andrew account in WSL is UUID 1000, so anything I run will be able to be attested by the Spire agent as a proper workload. I've already run this command. If I run it again, it's just going to say, oops. It's going to say failed to create. It already exists. So I do have a Spire agent running in, so a Spire server and a Spire agent running in these two windows on the right here, but that is largely not interesting other than setting it up. If you're interested in setting up Spire itself, I would suggest their getting started guide. It's what I used.
And I think you were
So
saying before, if you were going to do this, it in Windows and WSL, just make sure that you understand where you're deploying things, right? Because if you're
yeah,
running in WSL land, the networking, figuring all that part out is maybe tricky.
yeah. The other thing is that their guide has you open a Docker shell, and the it mounts your Spire directory that you're working with into it. So everything that you do gets saved in terms of that folder. But if you do anything like install tools and stuff, it does the standard Docker thing and forgets about them. I also, if you add Docker inside of with WSL with a Windows host and you're remoting, um, it's best to probably remove Docker and just go right into WSL and issue the commands, not using their Docker shell, simply because you then don't have to deal with transitioning from Docker to WSL and then
Networks and
WSL.
networks all the way
Yeah,
down.
networks on networks and networks. In this situation, everything is running in WSL.
Cool.
So there's no Docker here. Just so when you get Spire, you're going to get a whole bunch of files and folders and stuff, and this is what actually gets mounted into your the Docker container that they give you a shell into. Obviously, I've added things to it. These setups are obviously not part of it. This get intermediate CA, these are just scripts I wrote when I was walking through things, and I had to do things over and over to make sure they worked.
Where was the
There's
file that Spire created? Although it failed the last time, but what in here is that file?
Oh, that's not a file. We were creating a rule. We were saying
Oh, I see.
we were
I see.
saying for this SPIFFE ID, it's going to have this parent, and it's going to be attested, making sure it's running in Unix UID 1000. So
I
in
see.
order to get the SPIFFE ID, example.org/workload, you have to be running on UID 1000.
Very secure.
Well, yeah, I mean, there's
I know.
better selectors out there in Inspire to make things more secure, but this is the easiest thing because I'm not
Sure.
working with cloud providers, and I can just close my laptop and take it with me and keep working. I don't have to worry about having a connection.
Could you drop
Um,
one or two more examples of a selector just so I have kind of a frame of reference for the kinds of
um,
things?
Oh, yeah. So you can actually, so if cloud providers sometimes provide information that would only be known to that machine. So you can get things like credentials off from AWS. I believe there's things like you can get the ID of the instance you're running on and information like that. So like a lot of cloud provider type stuff.
Oh,
Um,
okay. For example,
MAC
in
address.
AWS, you can if you have an instance profile, you could look at the introspection REST API and say this instance has a valid ID from that particular instance profile or that particular ID.
Yeah, I'm not sure about that specific example, but that's kind of the flavor of it. You can also, I'm sure there's a lot of other things as well. Spire is also a Linux first, so the Windows support I believe is coming along, which is why I'm running everything in WSL. Um, but just as a warning, if you're going to try and run Spire on raw Windows, you might run into some problems. There's Unix pipes or Unix sockets that they use that, while they do exist on Windows 11 now, they're not implemented yet, and they do give you errors about named pipes, but it doesn't. No one ever explains how to set those up yet because it's all kind of in flux. Um, but uh, but yeah, so this is again is just the rule that says how do you get this SPIFFE ID, and this SPIFFE ID is going to go into an SVID, which is the cryptographically signed document, either a CERT or a JWT. In this example, we're going to use a CERT. And I do have a directory here called creds. If we go in here, there's a bunch of stuff. I'm actually going to remove all this stuff. Um, and there's basically no credentials anymore. If we look at this file, this is a Ziti identity file. It basically just says, where the creds are going to be and where the controller is to start getting running. And I'm going to run a tunneler that does this, but it's looking in this creds directory, which those certificates and private key don't exist anymore. So in order to get those back, we actually have to invoke the workload API. And so if you are developing this yourself, they do have CLIs that you can embed in your own applications if you would like to be able to invoke the workload API from your application natively. So you don't have to run a separate script. If you want to run a separate script, that is completely up to you. For my demo, it's pretty easy. But this is the command. It's Spire Agent API fetch. We're going to fetch an X509 certificate. By default, it doesn't write them anywhere, but I'm going to write them to the creds folder. I'll just copy and just run this. So what this is going to do, it's going to look at all of the information that the agent can see about me, and it's going to say, yeah, you match some criteria. I'm going to give you this workload ID. And so we can see that it wrote the SVID to, which is an X509 certificate, to svid.0.pem. Then we have svid.0.key to match with it. And there's also a bundle as well. The bundles are interesting because if you have a large number of trust domains and intermediates that have been spawned, that bundle can become very important. For us, since we have a simple setup, this file right here is going to be the most interesting one. It comes with the client cert and then the immediate intermediate that signed it, which is then signed by the root.
The immediate intermediate.
Intermediate, yes. So in this PKI, we have our root CA, which is the dummy one that came with Spire. Another intermediate was spawned from that root CA and signed, and then a CA was spawned from the root, which creates an intermediate. That intermediate was then used to sign the leaf, which is this client certificate right here. If we can actually take a look at this dash text. So it's only going to give us the first one, which is the one we really care about, but we can actually see our SPIFFE ID in here. So example.org/workload. This is the actual ID itself. It's embedded as a URI SAN, and obviously we can see it's been signed and all those good things. So this is the actual certificate that we're going to use as our client certificate for the Ziti tunnel to connect into Ziti. And Ziti is going to notice that the incoming client certificate is a SPIFFE ID. It's then going to go say, hey, do I have any SPIFFE CAs registered with me? And I'll show that in a second. And it's going to say, if I do I trust this? Do they actually validate and verify? Do you have a question, Ken?
Please go on.
Yeah. So if we actually take a look at list CAs, we can actually list the CAs. Oh, I didn't work it fast enough. Got logged out. This document looks, we're reformatted. We're working on the CLI tool. This should look a lot prettier soon. Let me just list CA. Let me put it into just the JSON view because it's a little easier to look at. So coming back, we only have one CA, and I added this earlier, and it's SPIFFE.ca is the name I gave it. This is the public certificate for the root CA, and I already verified it too. It is verified true. The actual
When you said you already verified it, I think what you're saying is there's a little dance that one needs to go through when adding a CA, right?
Yep.
And part of that dance is creating a certificate that was created that was actually signed by that cert, and if you do all that little dance, then it becomes valid, right?
Yeah,
Yeah,
that is
cool.
correct. Yeah. And we have helpful commands to do it for you. So as long as you have access to the root CA's key on some machine, you have to go to that machine. If it's offline, you have to online it, create the verification cert, and then come back.
Cool.
So this is actual command that I used to create it. We can see that I named it SPIFFE CA, and we gave it the path to the root certificate. We can actually take a look at that real quick. I'm not going to run it. It's going to fail because I already created it. And it's going to say a unique name error.
Okay. Quick recap, just stating the obvious here. There's a built-in ability in Ziti to trust external certificate issuers. And all we're doing is creating a trust relationship between the intermediate issuer that you created for your Spire setup and your existing Ziti controller.
Yep. And in the diagram, it's represented by this dotted line here. So this isn't a hard connection. This is essentially pre-configuration. We basically took the root certificate from the Spire server and said, hey, Ziti, trust this. And Ziti looks at it and goes, hey,
one-time operation.
And even the root CA, it has a SPIFFE ID inside of it. So we can say, oh, this is a SPIFFE certificate. So we know that it's a SPIFFE CA immediately. And actually, that's the command I just ran here. OpenSSL X509 in. I gave it the path to Spire's dummy upstream CA cert, and I'm outputting the text, which is right above here. And we can actually come in and we can see it's called SPIFFE://local, and it's a root CA. You can tell it's a root because the subject and the issuer are the same. And it also has CH.
One thing that's not yet perfectly clear to me is whether there is like a SPIFFE awareness inside of Ziti, or if we're just treating this as a certificate issuer at this point.
So it is both of those things. So we're treating it as a third-party CA, but there's a catch there because the SVIDs, the X509 documents that Spire generates, can have varying lifetimes, much shorter than what Ziti traditionally expects, which is usually a year, and then it's refreshed at some point in time. They can live for 5 minutes. And so what happens is that
ephemeral.
A workload might have to refresh its SVID repeatedly, and while the certificate changes, the internal actual URI SAN inside of it, the SPIFFE ID text itself, does not. That's the identifying characteristic. So for a SPIFFE certificate, what we're looking for is the SPIFFE ID in the SAN that is packaged inside of a certificate that has been signed by the Spire servers we trust. And so inside of Ziti, I had to add features in order to, when a certificate is coming in for authentication, I need to go through the SANs, look at the actual, look for SPIFFE IDs inside of there. And if I see them, try and relate them back to identities that exist that have an external ID set to that SPIFFE ID.
Got it. Okay.
Yeah. So it's very simple when you explain it, but it's
Oh yeah,
surrounded
that
by all
was
this pomp and cruft
so
of
easy,
signers.
Andrew. That was all so easy.
I know, right? Yeah. So that's what the root. This is what the actual root CA looks like. Basic things inside of here. So this, we're looking for this to know that this CA is a SPIFFE CA. So what we don't want is, we don't want non-SPIFFE CAs issuing certificates with SPIFFE like SANs that then essentially cross trust domains. And so there's some more work around here. We can actually become aware of the trust domains and a few other things that can make this a little more tighter. But for now, it's cryptographically secure, and as well
Cool.
as long as you configure it well. So that is what the cert looks like. I showed you the create command a second ago, and this is what the verify command, Ziti edge verify CA. I gave it the name of the CA. I passed it again the public cert, and I passed it the private key this time. And so what this command does is going to, behind the scenes, it's going to call to the controller. It's going to say, give me the spiffy.ca document, look for the verification code it's looking for, generate a very short-lived certificate that has that verification code as the common name, send it to Ziti, and Ziti says, okay, I believe that you actually have control over this CA now, in some fashion. And so that will make the CA become alive. If you don't verify your CAs, they can't be used for anything, no matter how you configure them. So again, looking at the CA in here, we can see SPIFFE CA, we have it verified, and we have auth enabled set to true. That's important. If you turn auth enabled off, no one can use it, even if it's configured correctly, because authentication has been disabled for the CA. And that feature exists in scenarios where you have a specific date and time in the future where you want a CA to become active, because a CA might have a lifespan of decades, but maybe you only want it to come online, June 31st in the future. And so you have some process that's going to flip it on at that point. So yeah, so adding the CA and verifying it, that's how we get this trust here. The next part is to actually, we already did, we have our files that have been output that now exist, which are the actual SVIDs themselves, so certificates that contain a SPIFFE ID. And we also have, as I said before, a Ziti identity.json that is pointing to those. So we're actually going to use those.
And
And
so that is a manual process right now, right? Like you had to go in and basically edit that JSON file.
yeah, I did.
Yeah.
I'm considering a way to kind of smooth this out a little bit is adding a separate tool set, a Ziti, like a separate SPIFFE focused tool set that'll also be embedded in the SPIFFE CLI to take care of this stuff for you. Like if you actually want to
In the
do this yourself,
SPIFFE CLI?
in the Ziti CLI.
Yeah,
I might have
you
misspoke
said
there.
SPIFFE CLI, yeah. In the
Sorry.
ZD CLI. Yeah.
Yeah. And so it'll be a separate CLI that's specifically like probably ZD-SPIFFE. And then because of the way we configure our CLIs, it'll be able to be embedded in the ZD one as well. So if you have the ZD tool, you can just use it. Or if you just want a much smaller binary that's SPIFFE focused, you can just use that one as well. That doesn't exist yet, but it'll basically replace all these scripts that I wrote, and probably actually
Yeah.
depend on the Spire project itself.
And it becomes more complicated when we start talking about mobile devices too, because the mobile devices will use the key tool or the keychain for whatever it is. So um, I'm sure there'll be plenty of development around this. So again, all of this is dripping wet developer stuff. I just wanted to point out the fact that right now you had to go and manipulate this JSON file. That's all.
That's correct.
Cool.
Yep.
So at the highest level, Spire here is basically an elegant way, or it's a way of automating certificate issuance based on knowable facts inside of a certain environment, like a Kubernetes cluster or an AWS VPC. If you can set up rules that say, if these criteria are met, then give them a certificate, and then Ziti set up to trust that certificate.
Yeah. And what Ziti specifically adds in that scenario is it's dark services, mesh routing, and all the other zero trust end-to-end type things that you're getting. Well, as far as your zero trust goes, if you're embedding it in some app that's running in the cloud, obviously you have end-to-end zero trust. But if you're using a tunneler, your zero trust comes in a little
like
bit.
you said, if you're embedding in an app, and since we have the SDKs, you absolutely could just write an entire app that works with Spire and use Ziti.
Yeah, you don't have to wait for us to give you tools. Like, this is something you could go out and do today. The Spire documentation is really well done, and their code base seems to be laid out well as well for
Nice.
reuse. Yep. So I'm gonna list my identities real quick one more time. I'm just gonna show. Let me pipe it through JQ so we get some pretty colors. We're not looking at the default admin. This system only has 2 identities, and so we have ZD tunnel right here. And you'll notice I didn't. There's no enrollment, by the way, for doing this. I created the identity and I said it has this external ID because enrollment is
Really?
for issuing certificates, and Spire is taking that over for us. So we
So I
don't.
was
There's.
actually going to ask the question if you could. So I just expected that you enrolled the identity and then just modified the JSON file,
I
but
just
you
told.
just made a JSON file instead.
I just told. The only thing I did was I told ZD there's this SVID, and I put it in this identity right here, and I said
Neat.
that's it. There's no enrollment. It's like whatever the rules are to attest the node to give it a certificate, that is outside of ZD's purview now. Like, you're now using the power of Spire to get the certificate. And what you
Like
do
it.
with that certificate could be a number of things. You could be doing signing things, you could be doing whatever you want to do with that certificate. But if you want to contact other services and you're just doing it over the internet in the raw, that means you have servers listening, and that's where ZD comes in, and we can actually make all those services dark for you. And then
Cool.
on top of that, you can use this identity inside of ZD with ZD's policies to control what services they can actually access. So yeah. So to make this all work, technically it should work.
Ooh,
Let's
we're going to see a
see.
demo now.
Yeah. So up here on the top, I just have Netcat running, listening on 7070. This is going to be the client. It's going to be trying to contact on 777, and we're going to be running Zini Tunnel Proxy. I'm going to give it that identity file that points to the SVIDs that Spire created. I'm saying I want to connect to Netcat, the Netcat 2 service. It's called 2 because this is all based off of my normal like local dev kind of run of the mill stuff, and there's a Netcat 1 and a Netcat 2 for different types of termination. Netcat 2 is router terminated, and we're going to be listening on port 777. So the client is going to connect on 777. It's going to go to the tunneler. The tunneler is going to send it to the edge router. The edge router is then going to terminate it back to our Netcat server here. A little roundabouty. It's obviously all in one machine. It's an interesting setup, but it's great for development. So one thing I want to do, I want to list my services just to show what that looks like. Let me just put that as, space. Just to show, I only have one service in here, which is Netcat 2. And so it's basically, there's a dial bind. I set up all the policies beforehand, and it has a terminator, which goes to, the Netcat server that we're going to be looking at. So there's the terminators. And we can see somewhere in here, we're going to TCP localhost 7070 in here for this terminator. And this is the terminator that Netcat 2 is associated with. Okay. So we're going to start up the tunneler here on the left. There's going to be a bunch of spam. Of course. Failed to load configuration from identity is, I'm not in the right directory. Let me go into Aspire because we need this creds directory, and we also need the zd.json. So let's run that again. So this stuff that came out, it basically says, tried to flush cache just because tunnelers usually try to do that to make sure that their rules are listed first. But it says at the bottom here, service is listening. So that means what it did is it took the SVID documents that were issued by Spire and used those to connect to ZD. And ZD said, I know who you are.
So
And now,
already we can prove that it has worked because the tunneler was able to find the Netcat 2 service and was able to connect to the controller. So if those certificates were not valid that tunneler was presenting, you would get shown the door. It would not actually allow you to even get this far.
yeah, that's correct. It would have
So
crashed
that's
out a
really
lot
the
sooner.
demo. Everything else now is all just extra.
Oh yeah. Yeah. Woo, data goes across from Netcat to Netcat. Yeah.
Yeah.
That is the main demo right there. And so we can do another thing. So let's go
So
go
out of curiosity, if you were to revoke that CA,
yeah,
then that tunneler would not work.
it will not.
Super neat. Oh, is that where you were going?
What did I call Spire.ca? Yeah, I'm pretty sure that's it. Yeah.
Spiffy.ca.
Spiffy.ca. There we go. Now if we come over here and we try to wrong screen, try to run this bad boy, let me clear it first. And just
Boom.
failed
Fatal.
authentication. Yeah.
Authentication failed.
The other thing
Super
you could do is
cool.
you can also delete the identity as well, or revoke the policies on the identity.
Sure.
Deleting the identity would cause authentication failure. Revoking the policies would allow it to authenticate, but then it would say service not found.
Wow. Well, that was really neat. Is there more, or is that? I mean, I feel like that's the crescendo.
That's it. I mean, it works.
Boom. Where's the mic? Drop the mic.
I can't drop it. It's on an arm.
Awesome, dude. Well, that was really cool, man. I have lots of ideas swimming through my head. I am eager to be able to try this. What sort of things are on your mind where how we might use this? I'm thinking about being able to give a random person access to a service if they provide me the right information. I can go make a spiffy rule and then they can just try attaching, right? Like, is there anything that you've already thought of that you'd want to use this for?
I think our smoke instance would be a real interesting place to do it because
Hmm.
those already run. I mean, we want to, those already run in AWS, and so we could really, you know, exercise a larger portion of smoke because smoke's what smoke does right now is it tries to make sure connectivity is good, and it by the fact that connectivity good, it ancillary is checking these other features like policies and terminators and whatnot, but it's not really exercising like third party CAs. And so if we make our smoke run on third party CAs using SPIFFE, that exercises that system. So that's standing up say Spire, registering the CA, verifying it, like it just increases the scope of what smoke does because smoke is really kind of focused on that end-to-end connectivity experience right now. That's what it's really testing because that's the thing that's actually hard to test locally. Whereas a lot of the back-end security policy stuff that's like delegated to our unit tests and our API tests.
What if I was doing something crazy? Like if I made two separate ZD networks, could I have one Spire implementation that serviced both of those networks? Would that
Yes.
would that wow, that'd be pretty neat.
Yeah, you could do that. I mean, technically, if you have two ZD networks, you can add each ZD network to each other as a third-party CA and trust each other's
We
identities.
haven't done that yet, have we? Because I think that's pretty neat too.
Whoa.
Yeah. Yeah.
Yeah.
Spire has a very similar setup. They have the ability to federate Spire instances, but ZD's had the ability to federate ZD instances from 2019, 2018, somewhere around there. Ever
Super
since
neat.
third-party CAs have existed, and third-party CAs they also have an analogous kind of like sibling feature, which is the external JWTs. It's kind of the same thing. So if you have a JWT provider, you can federate across that. Um, ZD doesn't issue JWTs right now, but there's a set of features that are forming right now where we're going to be able to do that in the future. So you can create, it already has the ability to create short-lived session certs. They're called ephemeral session certs, but we're also going to be adding the ability to do JWTs as well and support, say, Open Connect ID so that if people want to use ZD as their identity provider, they can.
So did I understand correctly that the new SPIFFE rules that are forthcoming in Ziti are going to
Oh, this
enable?
has nothing to do with SPIFFE. That's just capabilities that are going to be built into ZD.
Yeah, about the external JWT signer and stuff. But I mean, just zooming out on the SPIFFE stuff, well, the Spire implementation for Ziti that you're working on. So I'm familiar with posture checks, which means I can write a policy that says if these criteria are true about the endpoint from the perspective of the Edge SDK, then if it makes an attestation that these things are true, then I'm going to check those boxes on the policy. And if everything aligns up, then we're going to let the connection happen. Does this add to the same idea, where is this, that is, this is an authentication policy, not a connection policy, right? So this allows me to get this allows me to bring my own certificate from my Spire issuer if the Spire criteria were met. But then because of that awareness, I'm trying to find the best way to say this, that's in Ziti based on the Spire URI, can I then write rules that allow certain things to happen, only certain things to happen if it's a certain SVID? Is it key on the SVID, or is it just whether or not I have a
It keys on
certificate?
the ID. The SVID is the actual document itself. Um, right now there's no, the only thing that's looking at the SPIFFE ID right now is authentication. So there's no addition to posture checks to do anything with them. There's
Okay,
no, so you would, so there's a translation of the SPIFFE ID to a Ziti identity,
to a
and
Ziti
then through
identity.
the Ziti identity you get all of the posture checks, you get all of the policy control and whatever. What Spire and SPIFFE really bring to the table is a much richer cloud awareness and attestation model for workload scenarios, which is not traditionally, like, so that was never a focus of Ziti. We always said you could do it, but that kind of deeper integration with like cloud providers and being able to attest, workloads like that is something that, like, if you want them, bring Spire, because they did a great job. They did a fantastic job. So just
Kubernetes
use
maybe.
them. Yeah.
Um,
So you mentioned something at the very beginning about auto enrollment, and I missed a little bit of that. So I wanted to just
Um,
fill in the gap there. I'm familiar that with ZDCA, external CA ideas, where there are two different ways that the identities can come into existence from an external CA. Either they can be created in advance with identity specific attributes and names and things like that, or they can be created the first time the certificate is presented based on an algorithm, like get the
mhm.
name from the certificate and things like that, and always give the same attributes to all of the identities that are created from the same CA. So does Spire work with both of those or only one of those?
The are you talking about the Spire support in Ziti?
Right, mapping to an identity, does it need to exist in advance or does it work with auto enrollment also?
Based on the 2.5 days of work I put in right now, the auto enrollment feature doesn't do it, because the
Okay,
authentication code right now, it branches. It says, the first thing it does, it says, do we is this hard registered with us, which for a SPIFFE ID is most likely going to be false. And then it says, okay, are you a SPIFFE ID? And then it goes into the SPIFFE logic, and that SPIFFE logic right now does not support auto enrollment. But it should be a trivial thing to add, because we can just check to see if the SPIFFE ID is in use, and if not, just create the identity. It's
sure,
probably 10 minutes of work, and then probably about 30 to 45 minutes of writing tests.
sure.
I would
But
say I
day
would have said
zero
3 days.
Oh yeah,
for
well
Andrew.
then, unless
Yeah.
I get interrupted.
That would never happen. Okay, so auto enrollment, possible follow on, day zero,
Yeah, it will
probably
be.
mapping to an
It will
existing
be.
identity.
Yeah, and I also think we want to. So SPIFFE IDs, their URI, they have like a specific format. Something we've always considered adding to for auto enrollment is uh, rule based attribute assignment. And so I was thinking, maybe for SPIFFE, because SPIFFE is like kind of, it's a locked in spec. There's only really one way to prevent SPIFFE IDs. There's only one format. So we could kind of do like glob pattern matching on the SPIFFE IDs to assign attributes. So instead of just having one set of attributes that come in, when a SPIFFE ID comes in, we can take a look at the
Yes.
the pattern of the URI and like match on different parts of it, and then apply different attributes. But that's like a much richer engine. Like that'll probably be a follow along feature.
I was also thinking along those same lines of ephemeral identities, even. So, like, instead of having the necessity of a persisted identity, if you had an ephemeral identity that basically, manifested with given attributes, those attributes would then give it access to
Yeah,
the services inside of Ziti. That'd be really neat stuff.
that's another conversation that I've been having, I think mostly with myself. I don't know if I've talked about it, but essentially transitioning, like really working with SPIFFE kind of struck that same chord that I think you're hitting on. I think a succinct way of saying that is turning X509 certificates, especially ephemeral ones,
Exactly.
into claims-based documents. So
Exactly.
so there's a problem with that, is that the best place to put those is in URI sans, and the SPIFFE ID requires that they're only exists one URI SAN. So in order to be compliant with the SPIFFE spec as it's
It'll
written
just be
now,
big comma separated list.
you can't do that. You can't do it.
So you're saying
So
there
I
can only be
actually
one SAN on the certificates and the user
one
certificates
URI
from this
SAN.
one URI SAN, as opposed to multiple, or as opposed to other SANs of other types like DNS IP?
No, just URI SAN. So SANs are, there's a number of categories. In the category of URI SAN, there can only be one for it to be a valid SVID in X509 format, which is very limiting. And I went. It was part of the spec that I took umbrage. I don't know if it's quite that adversarial.
Umbrage.
I was just like, man, that makes my job harder for what I want to do. And so I reached out and I put an
How
issue up,
dare
and
you limit Andrew Martinez like that?
and well, their reasoning is they wanted to make it simpler, which it does. But in order to work with URI SANs, anyways, that you're working with an array of some kind, so you have to check to make sure the zero exists and then use it. And then you have to parse your URI, and if it's not a SPIFFE URI, you still have to make sure it's a SPIFFE URI. So like, adding a for loop around that doesn't seem like a huge deal to me. But I reached out, I put an issue
Yeah.
on their GitHub, and
Or
there's
it
been
makes
some
sense that they
conversation.
would limit it to try for the sake of simplicity, at least at this stage of maturity.
And what
Yeah.
So
about
this
oh, go ahead. Can you add one
this
more?
addresses a major limitation that I'd run into in playing with external CAs, where I was basically thinking, well, in order for me to make this work with auto enrollment, I'm going to need a large array of CAs to represent each set of distinct attributes that I want to auto assign when the identity is created. And if we do add this additional richness that you described, that keys on the particular elements in that array of the SPIFFE ID, then we'll be able to write those rules that is and assign specific attributes based on specific properties. That's really
Yeah.
interesting.
Yeah, there's kind of two ways. There's one, there's doing pattern matching on the SPIFFE ID itself to do the same thing, and then there's having claims baked into the document as well. In order for the claims to be baked into the document, I don't know, I don't have enough experience with Spire to know if it gives you the ability to add to the documents that it generates. I I don't know. That'd be an interesting thing to look at. But if it doesn't, you can always take Spire. It's open source and it's Go, so you can always add that capability if you really want to,
No,
or you could, suggest it as a feature.
I got one more. What about does I assume in the 2 days that you've already implemented this because that's so much time. But what about having timers on those certs? Like, are they short lived? When you think of ephemeral, you think of something that goes away. So
Yeah,
how
you
does
get
the authentication get revoked?
they're TTLs. So you can set in the rule. We didn't specify the time to live, so it took the default. So those certs actually have they actually have an expiration date, and so in Ziti
And
you
ZD
can
checks that routinely, like, every minute or whatever to verify that, do we set a deadline when you first authenticate? Are you authenticated until you disconnect, or do we set a deadline?
uh Ziti works slightly differently because once you authenticate, you get an API session, so it transfers it down to that, and the cert is now no longer part of the equation in terms of that. Reconnecting though is a thing, because when you reconnect either to authenticate or you reconnect to an edge router, you if it fails connectivity, you won't get it. But we're not currently auditing in a loop on the edge routers. That's probably something we need to add. We're going to need to add it for another feature that we're already coming to.
Ooh, can't wait.
Yeah. But um, with the way
Sweet.
it works for TTLs, authentication policies inside of ZD, which were introduced in the last release, I think. There's so many releases, I always forget which one's which. Um, you can decide to ignore expiration dates or not if you would like to on client certs. Um, but if you're enforcing them, then they won't be able to use the cert once it
Sweet. I did
expires.
not realize that came out with authentication policy.
It was
Nice.
buried in there amongst the other features that it brought forward. So
Nice. Well, we're at 54 minutes. I think this was one heck of a ZD TV. Andrew, thank you for taking us on a tour of this very dripping wet code that is not going to be released at the moment, but will be released shortly. So don't go try this at home just yet, unless you're watching this a month from now. Then who knows? Maybe it'll be out there. And that's all I have. So thanks again, and we'll see you next time.
thank
Bye.
you.